This video here is meant as a very brief introduction to computational chemistry, or modeling as it is also called. So what is actually computational chemistry? Well, in my view, computational chemistry should be seen as a virtual chemistry lab. It does not in any way mean that it substitutes the real chemical lab, but computational chemistry should indeed be used as an integrated part of chemical research. When you do chemistry, many of you are probably most used to being on this side here of the slide. That is, to go into the lab and to perform real physical experiments. What we do in computational chemistry, and what we should learn in this course here, is that we can also perform experiments, but basing them on theory computations, in this case here by solving the Schrödinger equation. So if I should define computational chemistry again a bit more specifically, then I would say that this is the use of computers to help us solving chemical problems. And the way that we work in many ways is that usually we start out by having some chemical problem here. Then we construct a physical model, and we will talk much more about the physical models here in this course here, which we can use in order to describe the chemical problem. We make the physical model quantitative by giving it a mathematical formulation, and finally we put it into a computer program. And this can now be used here to simulate the original chemical problem, and by inspecting the results and by analyzing the results obtained from these computer programs, we can then learn about our original chemical problem here. So the tools that we use as computational chemists, well, these are the tools that we are going to talk much more about in this course here. One very important tool is molecular visualization, simply to view molecules on the screen. We also make more quantitative stuff, that is, we make calculations, and these calculations can be based either on molecular mechanics, that is, classical mechanical methods, or they can be based on molecular orbital theory, that is, quantum mechanics. And again, we will go much more into detail what is actually behind these methods here. For now here, I would like you to use just 5 minutes here to try to come up with some examples of chemical problems which in your view could actually benefit from computational chemistry. So could you try to think about some chemical problems which would be very difficult to solve or to attack using experimental methods, but on the other hand could be very easily attacked using computational chemistry.